Let's do a couple examples of finding the inverse algebraically. So I have these functions. Notice I have some limitations on the domain on these two functions. I'm doing these so that these are actually invertible. So the inverse is a true inverse, always undoes it. And I need to find the inverse algebraically. I don't know if I need to. That's what I've been asked to do, and I'm going to do it. So, finding the inverse. Remember what the inverse does. It switches inputs and outputs. Switch the x and the y. So that's what we're going to do. Algebraically, we're just going to rewrite this as x equals 2/3 y plus 5. So, now that I've switched the x and the y, I want to come up with a function that I can plug in the input and it's easy to compute the output. So I'm going to get y all alone. I'm going to get that output all alone. So first thing that I'm going to do is subtract 5 from both sides to get rid of that part. So now I have x minus 5 equals 2/3 y. Next thing that I am going to do, I notice that I have this 2/3 times y. I could divide both sides by 2/3. It's kind of going to be ugly. So I think that what I will do instead is I will multiply by both sides by 3 halves. Not much room there, but I'm going to multiply by 3 halves. So notice what happens here. This is like 6/6, which is just 1. So once I pull off that little trick, this is just a y. This is 3 halves multiplied by x minus 5. And that's good enough. That's my inverse. I can distribute that 3 halves in there if I want to. I don't have to. So this is the inverse of that. Those two processes undo each other. Next one. Y equals 2x squared minus 7. I have this domain limitation on it. Again, that'll cut my parabola in half so that I only have the right-hand side, so it's invertible. So, in order to find an inverse, again, what I do is I switch x and y. So x is going to equal 2y squared minus 7. And now what I want to do is get y all alone. I'm going to solve this thing for y. So first thing I'll do is I'll just add 7 to both sides. And doing that gets rid of that minus 7 on the left. So now I have x plus 7 is equal to 2y squared. And now if you'll notice over here on the right hand side, if you'll notice over here on the right hand side, it's 2 multiplied by y squared. So what I'm going to do then is divide both sides by 2. And if I do that, I get left with x plus 7 over 2 equals, sorry about my ugly equal sign, y squared. Undo squaring by square root, so the square root of x plus 7 over 2, and make sure you draw your square root so the whole, it's square rooting that whole thing, is equal to y. That's the inverse to this function with that limitation. Last one. Find the inverse algebraically. So switch x and y, just like we always do. That's what inverses are all about. So I get x equals quantity y minus 4 squared. And now this one is a little bit different than the one before because my squaring is outside. It's out here. It's actually the last thing going on. So I'm going to undo that squaring first, and then I'll undo the minus 4. So square root both sides. If I do that, square root both sides, notice what I end up with is square root of x equals y minus 4. Now I just got to undo adding 4. I'm sorry, undo subtracting 4, which is adding 4. I like it when I say the answer when I meant to ask the question. So I end up with square root of x plus 4. Notice the plus 4 is outside of the square rooting equals y. This process undoes this process given that limitation.